Welcome back to Calculus 1. We're working on problem number 11 from part 2 of homework number 4. The solutions, now because there's two of them, the solutions to this problem are -5 and 11. And I think it's really worth watching this video to see how we get those values. For this problem, we need to find all x's, any real numbers, such that the absolute value of x and x minus 3 is equal to 8. Now, here's where not memorizing a formula, but remembering what we're actually looking for and what absolute value means will make this problem significantly easier for you than trying to remember the formulas that you used to do when you're maybe working in, I don't know, algebra 1 or 2 in high school. So here's how we're going to approach this. What we want is we want the distance. Here's what this guy right here says. We want the distance between some number x and some number 3 to be equal to a value of 8. So let's draw out what that says. That says that on a number line, here's 3, and then x is some, so here's 3 right here, and then x is some other number. It doesn't say whether it's to the left or the right, so it could be either, okay? So let's put one of them over here, and let's put the other one over here. I guess I should maybe space them out so they look even. Okay, oops. So let's see here. But here's what we want. We want the distance, because that's what absolute value means, is distance. So the distance of some x minus 3. So some distance between some value x and some number 3 to be 8. So what I need is I need this distance right here to be 8, and I also need this distance right here to be 8. So notice that there are two solutions. So one of these x values, when I add 8 over here on this side, 3 plus 8 puts me out here at 11. The other one, now notice, if I plug in 11 into this, what we're trying to find is the solution here. So if I plug in 11, I have the absolute value of 11 minus 3 is equal to 8. So let's make sure that this balances. So this is the absolute value of 8 is equal to 8. So yep, 8 is 8. So we're good. It seems kind of redundant, but look, that's the algebra. So now let's try the other side. So for our other solution, if we go back 8 this way, we end up over here at -5. So let's see if that works. Then we would have x, which is -5, minus 3, and we want to show that that's equal to 8. So that would be -8 is equal to 8, so the absolute value of -8 is 8. And so our two real numbers that work up in this guy right here are -5 and 11. So how is this normally done? Well, the approach, the algebraic approach, or the approach that you probably learned in, let's say, middle school or even high school, is to take what's on the inside and set it equal to the positive and the negative of this. So what they tell you is they say, okay, take x minus 3, set it equal to 8, and then take x minus 3 and set it equal to -8. And then they tell you to solve. Now, watch, it does work. Okay, so this gives you 11, and this gives you -5. Look, I got both the 11 right here and the -5. In this technique, though, it's not clear why do we set it equal to the positive and the negative. Here's why. In the event that your x value is more than 3, then the absolute value of x minus 3 is equal to x minus 3. So if this is positive, which was this case right here, then it's equal to just this. So what you have is this guy is equal to this, and remember we wanted this guy equal to 8, so that means this is true. So this is part one. The other thing that could happen is that this guy inside here is negative. Okay? If this guy is negative, that means that x falls to the left of 3, which means that this, so this is going to be the negative 5 version, so watch, this is equal to negative, right? Because that's when it's negative on the inside, we put a negative on the outside. So that's also equal to 8. So where did this crazy rule come from? Well, it's right here. First, you set it equal to the positive version. Look at that. It's right there. And then you set it equal to negative. Well, that's not quite true. What you really do is you take the opposite of the inside and set it equal to the positive of the outside. But now if you multiply everything by -1, there's this right here. So the rule that you were taught a long time ago comes from the definition of absolute value, and I bet you the majority of you out there, you were not explained that as a student, and that's too bad, because I think that if you see it this way, that it makes much more sense of why you're doing what you're doing, and you're not just memorizing a formula. And guys, that's what math is about. So